In this presentation, we will talk about multi-view sketching. Multi-view drawings show two or more two-dimensional views of a three-dimensional object. They provide the description of the shape of an object, and when combined with the dimensions, multi-view drawings serve as the main form of communication between designers and manufacturers. Here's an example of a multi-view sketch of a dining room chair. Note that the hidden lines are not shown for simplicity. Here's another example of a multi-view. Please take time to really look at this object. You will see this object many times throughout IED, and this is a really good example of a multi-view because it shows the different types of lines and correct usage of dimensions. Angles of projection are often referred to when talking about multi-view drawings. First angle projection is a standard used by European countries. They have the front view in the top left corner of their view orientation. The top view is below the front view, and the left side view is to the right of the front view, as seen in the bottom left of this slide. Third angle projection is the standard that is used in the United States, where you'll notice that the front view is in the bottom left of that view, and the top view is to the top of that view, and the right side view is to the right side of the front view. All three-dimensional objects have width, height, and depth. Width is associated with an object's side-to-side dimension. Height is associated with an object's top-to-bottom dimension. Depth is associated with an object's front-to-back dimension. A typical multi-view drawing includes a top view, a front view, and a right side view. There's the top view. There's the front view. And there's the right side view. The isometric view shows the width, height, and depth in one view, but the top, the front, and the right side views allow a designer or a drafter or an engineer to really describe the features and the dimensions of the object so that it can be manufactured. Notice that these views are lined up so that they line up together. Notice that the top is lined up with the front is lined up with the top view, and the right side view is lined up with the front view, and those need to be done when you're sketching and when you're making CAD multi-view drawings. Notice that the height dimensions are in the front view and the right side of view. Notice that any width dimensions are in the front view and the top view. Notice that the depth dimensions are either in the top or the right side view. Again, notice that all views are lined up so that construction lines can be used to help project the views from the first view drawn, which is typically the front view. Orthographic projection is a technique used to create multi-view drawings. Orthographic projection is any projection of the features of an object onto an imaginary plane of projection. The projection of the features of the object is made by lines of sight that are perpendicular to the plane of the feature. The best way to understand orthographic projection is to imagine an object contained inside a glass box. There are a total of 6 glass walls surrounding the object. Each wall represents a projection plane onto which a two-dimensional object view will be created. The projection plane is also referred to as a plane of projection or picture plane. The projection plane is an imaginary surface that exists between the viewer and the object. It is the surface onto which a two-dimensional view of a three-dimensional object is projected and created. Start by focusing on the front projection plane. A person standing in front of the object would see only the 5 corners identified in black. Projection lines are used to project each corner outward until they reach the projection plane. A projection line is an imaginary line that is used to locate or project the corners, edges, and features of a three-dimensional object onto an imaginary two-dimensional surface. The visible edges of the object are then identified on the projection plane by connecting the projected corners with object lines. The orthographic projection process is then repeated on the other projection planes if they are required. Typically, we only show three: the front, the top, and the right, but in some occasions you may be required or you may need to create a bottom or left or even a rear view. To create an orthographic projection, you will first need to decide what is the best front view of the object. The following are recommendations for how you could select the best front view of the object. The side of the object that is its most natural position or use. The side of the object that shows the best shape and features of the object. The side of the object that may contain the longest dimension or dimensions. The side of the object with the fewest hidden lines. The side of the object that appears as its most stable and natural position. Here is an example of choosing the best front view of an object. Notice this object's best front view is located with the red arrow. Because it includes the best feature or shape of the object, it shows no hidden edges and requires no hidden lines, and it includes the longest dimension and appears to be the object's most natural position. There may be times when only one view is required. If the part has a uniform thickness, such as a flat plate, or a uniform shape, such as a cylindrical shape. If the two views would be identical and all dimensions could be properly and easily shown in just one view. There may be times when only two views are required. If the part is symmetrical, which would cause a third view to be the same as one of the other views. However, a second view would be necessary to show a depth that is not constant. Given the overall dimensions of the object, a pencil and a sheet of graph paper, sketching a multi-view drawing can be easily done using points, construction lines, and object lines. First, lay out the boxes or the areas within which the individual views will occur using points and construction lines. If you're using graph paper, this process will be a lot easier. Notice that the front view, top view, and right side view would be drawn in the blue highlighted areas. Next, use construction lines between the views to indicate the geometry of the views. Next, identify the visible edges with object lines. Next, locate any hidden lines. Notice these hidden lines represent the backs or the bottom of the slots shown in this object. Each of the objects to the right have the same overall dimensions and color. But what else do they have in common? Take just a moment to think about it. They all have identical top views.